Hi girls, welcome back after the break. I hope everybody is safe and well. Okay, hope everybody's families are doing good. Alright, so we will keep going on regardless anyway, okay, and try and get another little bit done before we break for the holidays, okay. So we're going to finish off the end of the area and volume chapter, so that's here with the trapezoidal rule on page 103. So what the trapezoidal rule is used for is for finding the area under a curve. Okay, so something like this, where we're looking for the area under a curve. All right, so hopefully you remember what a trapezoid is. Okay, so your four-sided figure where two of the sides are parallel. All right, and what it's telling us there, it says the area under the curve is approximated by trapezoids of equal width as shown in the diagram. We can then find the sum of the areas of the trapeziums. For the 5 trapeziums shown, okay, so what they're doing is they're getting the area of each trapezium, okay, using the trapezoid formula, and then adding them all together, okay, and we have a formula for this, and it's all divided up. You can see each width is the same. Now, I've always hated that they use the letter H for width because, you know, it's typically our letter for height, but we have to get our heads around it, and H is the letter they use in the formula. So it's broken up into the same width here, okay? You'll see it depends on the size of the shape and how accurate it needs to be, or what, you know, you can get it depending on the width of the trapezoids, okay? The formula is in page 12 of the Formula and Tables booklet in the format that it's in the green box there. So it says the area is approximately equal to, so the kind of squiggly equal lines mean approximately equal to h over 2 times y1 plus yn plus twice y2, y3, or 4, all the way up to yn minus 1. Really, really complicated way of saying that we divide the width by 2 and we multiply it by the first number, add the last number, plus twice the rest of the numbers added together. I should probably write down sum of rest. Okay, so first plus last plus twice the sum of the rest. Okay, so they will have to give us all this information in the question, or sometimes they'll leave the H out, but they'll give you the answer. They'll give you the area answer, and then, you know, you'll work on it to get the H. What you must be really careful of here, and it sounds such a simple mistake, but it happens all the time, is BOMDAS. Okay, this is where people actually lose this question, even at higher level Leaving Cert, is with BOMDAS, because we have add the first and the last plus twice the rest. People very often add 2 to these two numbers. Okay, so add these together, add the bracket, so BOMDAS, brackets first, then multiplication, multiply the brackets by 2, and then add it to the first and the last terms. Okay, so we'll do a couple of examples anyway in a second to show you that. All right, so what we're looking at here is basically what you're doing is, with the trapezoidal rule, you are using the heights of the parallel sides of the trapezium, okay, and we're putting into the trapezium formula and we're adding them together. And what you'll find is if we join those heights together, okay, so the top of the heights like that, and there would have to be like, it's not from here to here, it has to be equal, but just looking at these 3 for example, okay, so we get the trapezoid, the area of that part, okay, using these as the 2 heights, but that's leaving out that bit of the curve there. But on the next one, we'll be getting that full thing, and we have this extra part above the curve, and what you'll find actually happens is it balances out. The narrower your strips are, if each of those is divided into 3, say, okay, so you narrow strips, the more accurate you're going to be getting, because you're going to be getting nearer and nearer to the actual area under the curve. All right, this is a really good approximation. It does work very well when we do integration, which is a part of calculus in 6th year. We'll find out how to find the exact area, and you'll find actually that they're very close together. All right, so the easiest way to do this now is to do an example, okay? So I'm going to do page 104, question 1. Oh, sorry, just get the phone a wallop there. Okay, so we're looking at this one here. So it says use the trapezoidal rule to estimate the area of each of the following. So we know that the width of each strip is 2. So that's our h. We're going to write that down. Okay, so we're on this is page 104, exercise 4.4. And we're on question 1. Okay, so we know from this that our h equals 2. Okay, then each of these figures will be used in the formula. So our first is 4. Our last is 2. Okay, and then the rest are the values in between. So in this case, 5, 7, 6, 7, 3. Okay, so they're the rest, 5, 6, 7, 6, 7, 3. So I'm literally going to just fill in the formula now. Okay, sorry, I've scuttled the camera when I walloped it a while ago. Right, so we're going to do h over 2, so that's 2 over 2. Our first term is 4, our last term is 2, plus twice the rest added together. That's why I changed it to the sum of the rest, so we don't forget to add them. So 5 plus 7 plus 6 plus 7 plus 3. Okay, so 2 over 2 is 1 outside. Okay, so we have 1 outside bracket, and like I said, watch BOMDAS. Okay, this is the key area because it's simple to fill in values. 6 plus twice 5 and 7 and 6 and 7 and 3, that's 28. So it's 1 times, we can just get rid of that. 6 plus 2 times 28 is 56, giving me 62. And they told us in the question the units are in meters, so 62 meters square. And that's it. Okay, it's a really easy formula to use. Okay, so sometimes they can give one, like in question 3, where they have values above and below the midline. Okay, so we have our line here. Okay, you have 2 choices here. You can work out the top and work out the bottom and add the areas, or just deal with them as one. Okay, what I really want to point out to us here, you see the way this one has the blue line for the curve the whole way down to the bottom. You see in question 1, you know, it's up here with the height of 4. If it's all the way down to the line and there's no height written on it, the first is going to be 0. Okay, so we have a first of 0 there. And over here, this middle value here, we've 20 up here, but that would be a 0 also there. Okay, so we're not going to do this singly. I'm going to do it as a full question together. Okay, and like I said, you could do it the other way if you wanted to. That would be fine. Okay, so this is question 3 on the same page. Okay, so for my width, okay, all the widths, the h's are 2.5. And then for my heights, I'm going to add together. So I'll have 3 and 0 is 3, 4 and 5 is 9, 10 and 6 is 16, etc. Okay, so for question 3, I'm going to have, so 0 plus 3 is 3, 4 plus 5 is 9. 10 plus 6 equals 16. 15 plus 8 equals 23. 14 plus 9 equals 23. 20 plus 0 equals 20. 10 plus 12 equals 22. And finally, 5 plus 8 equals 30. Okay, so hopefully those two zeros were clear enough to know where they came from. Okay, so again, identify your first, your last, and your H. So my first this time is 3. My last is 13. And my H this time is 2.5. So we'll have H over 2. And then first plus last plus twice the rest. So plus twice 9 plus 16 plus 23 plus 23 plus 20 plus 22. And just work that out then again. Okay, so 2.5 divided by 2 is 1.25. 3 and 13 is 16 plus twice 113. Okay, so that's 1.25 times 16 plus 226, which is 1.25 times 242, giving me a total of 302.5 meters squared. Okay, so that's the area for that entire shape there, the approximation of it anyway, as close as we can get using the trapezoidal rule. Okay, so there are a number of questions here, okay, and a few different ways of doing them. I'm going to ask you to try them without me doing any more examples, okay? So I want you to try exercise 4.4. I'll write it up in the section there as well, okay? So exercise 4.4, you'll be doing 2, 4, 5, 6, 7, 8. Okay, thanks girls.